Yesterday we did the intensity of electric field due to a line charge, that means the first application of the Gauss theorem. Today the second application, that is intensity of electric field due to an infinite long charged plane sheet. This is the second application of Gauss theorem. For that we are considering this is a charged plane sheet. That means the charge is given to this sheet. This is a metallic sheet and the charge will be given to this sheet. This charge is uniformly distributed over this sheet and we have to find out the intensity of electric field at point P on either side of the sheet. For that we will consider a cylindrical Gaussian surface which cross the sheet. This is the cylindrical Gaussian surface. The difference between the first and the second application, in the first application the Gaussian surface, cylindrical Gaussian surface was vertical, and here the cylindrical Gaussian surface is horizontal. So in the previous, that means in first application, as I told you, the electric flux passes only through the curved surface, but now in this case the electric flux will passes through the two faces of the cylinder only. They are not passes through this curved surface, because in between the direction of the curved surface area and intensity is of 90 degree. The angle is of 90 degree. Therefore the flux will be equal to 0. So in this application the flux will be passes only through the faces of the cylinder. Now we will suppose the area of each face of the cylinder, that is equal to A. So therefore the total area of the two faces of the cylinder will be equal to 2A. Now we know phi is equal to E ds cos theta, but theta is equal to 0 degree. Therefore cos theta will be equal to 1, and therefore phi will be equal to E ds. Now ds is the area and that is equal to 2a, so therefore phi will be equal to E into 2a. Now using the Gauss theorem, phi will be equal to 1 by epsilon 0 into q. So from equation 1 and 2, their LHS are equal, so their RHS must be equal. We will get E into 2a is equal to 1 by epsilon 0 into q. Cross multiplying, so we will get E is equal to 1 by 2 epsilon 0 into Q by A. But we know that Q upon A, that is charge upon area, is equal to surface charge density, which is denoted by sigma. So therefore E will be equal to sigma upon 2 epsilon 0.